Welcome to the Demisto Tech Talk series. Today we are going to see how to do some memory analysis of an infected system using Volatility and Demisto tools. So let's start by actually creating a new incident in Demisto, which will be used for the cridex malware analysis. We have a system which has cridex malware and we have already taken a memory dump. So cridex malware. Let's actually just create this incident, create new incident, and this is the incident. And let's actually go ahead and take a look at this particular incident and start to investigate. So before we go any deeper, one of the things we have done is we've already taken memory dump using one of the tools of the system and placed it on the system itself in /temp folder. Now, there are multiple tools we have integrated for memory dump here that could be used, but to save time here, we have already taken the memory dump. So let's first copy the memory dump from that system to Demisto locally, and that can be very easily done by using a command called copy from. And as you can see, this is the Demisto war room where all these commands could be issued directly and actually executed on the target system or on the volatility analysis system, as we'll see in a little while. So here's the file. We know the file is in this directory, cridex.vmm, and we are able to pull this file from that system locally here, and we will give it the infected laptop. That's where we want to pull the file from. So let's do this. And here is where dbot goes ahead and brings that file back into Demisto. So there we see that the file has been copied from the target system, which is the infected system, back into Demisto, and we'll quickly see how the memory analysis looks. So here you see this is the entire memory dump that we brought back. This is the file. Now, the next step typically is in any scenario, if you were not using Demisto, you would take this file, copy to a SIFT workstation or another Linux system which has all the memory analysis tools. And then you'll do your analysis, copy paste results, come back here. In our case, we can do all of that from here. We've also configured already a SIFT workstation as a remote access system, if you see here. So if you see, one of the system that's configured here for remote access is the SIFT workstation, and we'll go ahead and push the entire memory dump to that system. So let's say copy to destination directory. In our case, what we will do is we will copy to memterms. That's the directory, and the file, we already have the file here. Here is the entry. We just click that and copy paste that entry. So that's the entry, and let's actually point out the system that you want to copy to. So that is our SIFT workstation, and we will go ahead and copy the file to that. So now the file is copied on the destination SIFT system. And let's start our analysis. So we have integrated volatility here, and it uses some of the other capabilities in Demisto. We can actually run these commands on the Linux system either using remote exec SSH, which is how we copied the file, or in some cases it might be better to deploy the Demisto dissolvable agent. So in our case, I'm going to actually go ahead and deploy the Demisto dissolvable agent. Let's give it the IP address here, which is the IP address of our destination system where we copied the file. And then we give it the credentials. I also have the credentials saved. And then the OS is Linux. We don't need to specify. We are able to auto detect this. But in this case, we'll do it. And let's give our system the name SIFT. And here is how we add the system SIFT to the investigation right here, which is now going to be used in all the analysis. So for example, let's start by one of the simplest commands, vol image info, memdump, and the memdump path for us is home ubuntu memdump slash cridex.vmem. That's the file, and we give it the system sift, and that's about it. Let's see if we are able to at least get the basic image info on that memory dump before we start the deeper analysis. So here we go. We are able to pull the information about that memory dump, gives the basic details, gives all the KDBG and other details right here about the memory dump. Suggested profiles are given here. So now that we have the image analyzed, let's do a deeper analysis. So let's actually, typically the first step after getting the image info is to get the PS list and get the connections list that were created for this particular system. So let's start by getting the PS list first. So use the up arrow command here, do PS list. That's it. And let's run PS list on this particular system. So here is where we get all the processes on that system running. So this is the process list. Fantastic. Typically also it's best to get your connections list. So let's run the vol con scan, and with again volatility con scan, we are able to get all the live connections for that system. And let's see, oh, we found 2 live connections. Both those live connections are with process ID 1484. We can quickly move up and see what is the 1484 process here. So I don't see it in the list here, do we? And PID right here on the right, 1484. Explorer.exe, that's pretty suspicious because explorer.exe doing a network connection outbound is not good. Notice also we auto detect things like IP address. These all look good reputation. This one look good reputation. This one look good reputation. Good reputation. So let's do a deeper analysis. 1484 explorer.exe making a network connection, definitely suspicious. So how about we actually use Volatility's malfind command to dump all the details. So here again, let's do memdump slash home ubuntu memdumps cridex.vmem. Oops, I mistyped it. I'm glad I catch this here rather than later. Dump directory. So let's just use slash temp slash dump agent to be able to get details. System is sift, that is what we are running the command on. PID was 1484. That is, we want to, basically this command is dumping the entire memory of 1484 into the file. So we want to see what is process 1484 for a deeper analysis, maybe static analysis, maybe looking at the reputation. All of those pieces. And let's actually use that. That's pretty much it, right? So all the parameters, and now let's get that process memory dumped, brought back as the file here. And typically, notice this, how quick was this? And you would have to kind of go analyze this and you will get the details and then bring that here. We bring all the output of volatility and we actually brought back the file. As soon as the file is brought back, its reputation is checked and we immediately see that this file is bad, detected by malware, detected as malware. Now, this clearly means that this is the process 1484, which is suspicious. Now, if you want to do a deeper analysis, you can actually do file command and give it the file. Let's actually give it this hash to get more details about this file from multiple different sources. So let's actually run that. Now we are able to use multiple different sources on that file, right? So we go silence infinity We are able to get the score from silence. We are able to get virus total, and it shows us bad, all the details, how many these things, and we clearly see what's going on. And Falcon did not find, CrowdStrike didn't find anything on this file, which is interesting. Just to recap, what we have been showing here is all the commands, all the memory analysis being run from this war room. The other capability right here, if you see all the stuff, so this was our memory dump. One of the things you should do is you should add as evidence as we go along. Memory dump for the infected system. Let's actually say we just found it. So mark that as evidence. Then this is the image info. I think it's good to capture this information. Image info for the infected system. This is where we took the memory dump. Then this was the list of processes. So I want to say list of running processes. And remember, we also found that 1484 is Explorer and has a network connection. Suspicious. So that and we are able to kind of, this is the actual malware, right? So let's take this and say dump of the process memory for 1484 and found to be malicious as per reputation. So that's actually definitely a smoking gun. And to close this, I think let's write a note, right? So it says analysis of the cridex malware. So what did we find? We found that explorer.exe PID 1484 has a network connection. The dump of the process clearly shows that it has malicious reputation. So we take that as a note, and we should actually highlight it so that anybody looking at this at a later stage knows what to do. So here it is. I think quick recap. Full analysis of cridex malware done from here, volatility integrated, and these are just examples of a memory analysis tool. Other such integrations exist for taking memory dump, copying files across, and many more. The beauty is, as you do this analysis, everything is tracked and captured. You never have to go off the tool and make copies, copy paste things, and then you started to create the entire storyboard, right? This was the memory dump. This was the image info, then list of running processes, then dump of the memory, all here and all indexed. So later on, let's say somebody comes back later and says, is there any artifacts for cridex and what has been done? And they come back into the system, another analyst, they will be able to quickly see right here and find all the details of cridex. So this is our cridex analysis in the entire system, and then they can quickly jump on and learn more about this particular evidence. So they can jump right here and learn the full thing. Thank you.